Thank you, Trevor. Hi, everyone, and kia ora. Welcome to the whiteboarding session on safeguarding your generative AI applications. My name is Gaurav Arora, and I lead the solution architecture function for partner team in ANZ. And I'm deeply passionate about enabling generative AI experiences through responsible AI and securely and safely. Now, I'd like to start with a personal story. It was way early in my life when I had my first-hand experience with what multi-layered safeguarding means. I think I was 10 years old. My dad, who's not retired, used to be a banker. So he used to look after a large bank, a branch of a bank in India. And during summer holidays, which is around same time, April to June, July, sometimes I used to accompany my dad to his work. And I used to love it. I used to get my own desk. I used to pretend that I'm working or doing my homework at the time, but what I did really was read a lot of comics, ate a lot of good food, and ran around, asked people how the bank works. Now, the bank dealt with a lot of cash, and they had this big gray room-size vault at the back of the bank on the left-hand side. And I used to pester my dad to let me in. And turns out you can't just roll in. There were strict protocols for people who can get inside the vault, and protocols around cash handling, coming in and out, etc. Now, question for the audience. Who has been inside a bank vault full of cash? Raise your hands. Oh, a couple of them. Aren't we the lucky ones? Now, as you can tell, I eventually did, pestering word. So one time there was an audit inside the bank, and there were people from headquarters, HQ came in to audit the bank's processes, the vault, the locker boxes, etc. And I was in the bank at that particular day. And my dad eventually came in and let me inside the vault for a few seconds, 5-6 seconds, along with a couple of folks. And that was after hours. And there I saw cash, but also surprisingly gold bullions as well, which was stored inside the vault. Now you're 10 years old. You just saw a lot of cash and gold. What do? Your inner James Bond came out. You start to think, what if someone tries to steal the cash and gold? What will bank do? And I started to notice things, but also started to talk to a lot of people. Turned out, bank had fair few measures to protect themselves if there was a robbery attempt and stuff. It's on, great. Now the first measure was, as you can see, there was a big vault. 10 inches steel, bolted to the ground, fireproof, shockproof kind of stuff. And as much as movies like Fast and Furious will have you believe that you can just tie the wall behind your van and snatch it and run around town and steal it, it's not going to happen. They usually bolt it very deep. So first measure there. Second measure was bit obvious. There were security guards with guns outside the bank and also protecting the vault as well. Next measure I realized was there were a lot of cameras monitoring the bank and also alarms connected to bank's headquarter, police HQ, but also a couple of police stations nearby, just in case they have to send someone to deal with something. The next measure was security access. Now, my dad was a bank manager, so he used to have keys to the bank, but also a couple of other people did it as well from security, for example. And they had biometric access to the big vault, and which was surprisingly advanced for 1992. And also, they had strict protocols. Vetted personnel were allowed inside the bank. I was a kid, so I was a special one in a good way. But also, they had 4-eye principle, as in minimum of 2 people, 4 eyes, would be inside the vault for cash handling and whatnot. And also, they had regular audits, etc. So they had strict protocols from processes perspective as well. Also, last but not the least, bank paid insurance to protect if there is something happens, and if there is a theft, they'll get the money and assets back. So all in all, you can see that they had multiple layers of controls put in. In case 1 or 2 fail on a particular given day, there are others which will keep the bank safe as a whole. Now that was 1990s. We don't really go to a bank branch to do your banking. You can still walk in, but usually we do our banking needs digitally. And also to and to safeguard a digital bank interaction, infusing generative AI, I thought that I'll just use an example, a common example of building an AI assistant, a chatbot. Now, let's assume that this chatbot is a end-user facing chatbot. A banking customer can log in and interact with the chatbot for understanding, getting their account information, password resets, but also be able to work with it to compare products and know more about banks' products as well, like home insurance, credit cards, loans, etc. Now, one of the first things you would do when you're building something like that is you try to actually define the scope and requirements of the chatbot experience. You want to know what are the features you want to support going in as a first cut. You want to understand some non-functional performance requirements, number of users. Also, what is the problem you're trying to solve with this chatbot experience? Or is there a new capability you're building in? Aligning your use cases to business processes and use cases will help, because that will help you propel to production faster. You'll probably get better investment going in. So let's assume we've done the right thing. We have aligned ourselves, we understood the scope requirements, and now let's start to build the technical architecture. Now I have some icons on the right-hand side which I'll use to build architecture, and also I'll use inside-out approach, as in the back-end first and then front-end. Let's start with our model first. We'll use Amazon Bedrock as a model provider. Amazon Bedrock is our managed service, allowing you access to leading foundational models on AWS, and models from 7 providers at this stage: Anthropic, AI21 Labs, Stability AI, Cohere, Meta, Amazon own model, etc. And they are available. You can access them within the console, but also through APIs as well. So Bedrock is our model provider. Second is to manage the response, to actually take the request and manage the response. We need something to process those requests. And the processing engine will sit on AWS Lambda. AWS Lambda is our serverless compute service. You can run code as functions using Lambda. And on that, we'll use Python-based backend. Plus, we'll also, excuse my handwriting, also use LangChain agents along with that as well. And folks who have not worked with LangChain, LangChain is a framework for both Python and JavaScript-based applications, which have inbuilt libraries. It makes it easier for you to interact with large language models, orchestration around it, and also the data source integration as well. Very helpful. So we use Python and LangChain for our processing. Now for data, we'll use a couple of services. First one will be DynamoDB. So I'll use DynamoDB to store all the factual data or information about my users. For example, I can use it to keep user information. I can put account information, and also I may also keep chatbot history as a place to chatbot history on that. So factual information about my experience. Also, another data source I'll use is Amazon Kendra. Amazon Kendra is our AI-driven intelligent search service. We can use Kendra as a RAG source. Now, folks who haven't heard what RAG is awesome. Retrieval augmentation generation. It's a technique for you to provide extra context when you're making requests to a model. So extra context as in context from your corporate product information, your intranet, and etc. So when you're making a response, you are getting some data out of your RAG source, and you're supplying that to the model, so that model is providing you opinionated response rather than a generic response based on whatever the data model is trained on. Very helpful for our use case. For front end, I'll use AWS Amplify. So our front end is an Angular project hosted on AWS Amplify. And Amplify is our service you can use to build web and mobile applications very quickly. And it supports all the latest frameworks, React, Vue, Angular, Gatsby, etc. So we'll use Amplify to host our web application. And also, within our web application, we'll also have Lex chatbot. So Amazon Lex is our conversational AI service, which you can use to actually create chatbot experience. It has AI-driven intent recognition. Also, it actually manages the context of a chat session as well, and integrates with rest of AWS services really well. And one feature I really like about Lex is you can actually use it to build multilingual chat experiences as well. So it supports other languages like German, French, Mandarin, Hindi, etc. Now, some of our components are already there. What's missing is our user. So let's see what the user workflow will look like. Our user is Kate. Kate is already a bank's customer, and she is in the market to get a new credit card. So she looked at a bunch of credit cards. Some are low interest, some are high interest. Some are high interest with a bunch of other features like frequent flyer points and whatnot. So she wants to have better understanding. So she wants to actually use chatbot to get that understanding, that comparison. So Kate will send a request when she logs in. She'll send the request to the chatbot, embedded chatbot within the web application to compare about the credit cards. Now, Lex will, based on the intent, will invoke Lambda handlers as a code hook. And based on the intent, Lambda will actually make a call to, for example, DynamoDB to get factual information about Kate. For example, account information, maybe she already has a credit card, that kind of stuff, as additional context. Now, also, Lambda will make a call to Kendra, in this case, to get credit card comparison information, because Kendra is where we are indexing our product information around credit cards, for example. So it will make a call to Kendra to get the top results from internal corporate information that, hey, what are these credit cards? Need some comparison points, etc. And Kendra will send it back to Lambda. And then we'll have Lambda combining the prompt request, which is Kate asking, hey, compare these credit cards, plus the context we got from DynamoDB, plus the internal RAG information we got from RAG source. Combine that, and we'll make a call to model hosted on Bedrock, and we'll get a human-like response, which will flow through to Kate. And response would be, hey, these are the 3 comparison points, and this is recommendation. Also a next step, if any, and that is a feature supported by the chatbot app. Now, I demoed this to my team, and it's working functionally. We test other requests and responses. Now we want to take it production. Now, do you really think that a bank will let this go in production without any checks and balances? I think not. So as I spoke to security team, risk team, because I had to, because I didn't think about it, they identified a bunch of gaps. So let me logically provide those gaps, combine those gaps and provide that. First one is access control. Just like my dad had security keys to the bank and biometric access to the vault, in this chatbot scenario, how do we know who gets access to a particular data set or model? We haven't actually proven that, demonstrated that yet. Second gap is, just like in a bank, you have node counting machine, not only count the node, but also pick up fraudulent nodes as well. And also someone to attest the gold bullions, which will be kept in the bank. How do you know what's if the data you have for validation, testing of your models and interaction is a good quality of data? And also, how do you evaluate which model to use to begin with? So going in, how do you actually, there needs to be a bit of a work done so that you have right quality of data and right model as a starting point. We haven't done that or demonstrated that. Next gap is auditing. All right, so just like bank got audited, it's not if, it's actually when someone will come say, hey, how do you know your chatbot is not perpetuating bias and is fair? Because that could be happening. And how can you explain the decisions coming out of the model when you provide the recommendation to Kate? What is the basis of it? Where is that coming from? So questions will be asked, because the responses may look okay at the face value, but the model could be hallucinating. So how do you make sure that there is an explainability side of things covered as well from the auditing perspective? The next area is, the last area is, where are the guards? Who is inspecting the request coming in and response is going on out, just like the guards will do. There's no inspection mechanism. How do you make sure that we filter out bad requests kind of thing? So there were 4 areas of gaps identified. Now, I have to address those before I can go to production. So let's go back to our architecture and see one by one how we can address those gaps. So what I've done is, I have depicted the architecture neatly. And on the left-hand side, on top corner, I have gaps identified so we don't miss any. Let's start with access control. Now, Kate, as a banking user, you would use CRN number, your reference ID, your password, maybe OTP, MFA to log in. We assume that Kate has done that. Kate does that. When she supplies that information, Amplify has a feature called auth. And auth is backed by or underpinned by another service called Amazon Cognito, which is our authentication and authorization service for web and mobile applications. So with auth will manage the whole workflow of federating the authentication back to banks, SAML provider, for example, like AD, LDAP, Okta, you name it. It will do that. But also once that is done, it will manage the whole workflow of providing the temporary credentials to Kate so that Kate's request goes through other AWS services. And those temporary credentials will have IAM roles and certain permissions provided at that time. So Kate makes a request, right, and goes to Amplify, and then she needs to access, so the logic needs to access the data which is very specific to Kate. And the data is sitting in DynamoDB. With DynamoDB, we can use IAM roles. IAM is Identity and Access Management roles with very granular permissions where we can control which table Kate can access, which item within the table Kate can access, both on a read and write operations perspective. So we can really control what a user like Kate will be able to access. Now, also from a model perspective, we can use IAM roles with granular access control on the model Kate can access or the request on behalf of Kate can access. The actions of Bedrock, like API calls, Kate can access, but also certain features and functionality of Bedrock, Kate's, the whole workflow can access. So we can really lock it down to very specific actions only. Now, fun part is brag. Now, you can use IAM roles again and certain permissions to lock down Kate's request can only go to a particular Kendra index because you can create indexes in Kendra. Now, all that data is indexed. All the corporate information is indexed from a product sales perspective, for example. But Kate is a retail user. And she probably will have access to certain product information which may not be same as institutional banking customers, like big investment houses. And they may have access to products which are not visible to retail people like us, right? So so how do you actually differentiate that? How do you actually segment that? Now, there is one way you can create separate indexes within Kendra for that. But also then you'll have to maintain separate indexes and manage the logic at a Lambda layer. But also what you can do is you can enable token-based user access control. And you can use tokens, JWT tokens, JSON, and OpenID tokens. So when Kate makes a request, Kendra is picking those tokens and comparing that with the ACLs, the access control list. Kendra would have gotten, along with the document it has indexed at the ingestion time, and that would have happened like a pre-processing job. And it will compare the token with the ACL to only, and to filter out and only provide results of the product information visible to Kate, so that she can only access whatever it's allowed to be accessed from a retail user perspective. So job will come, and Kendra will provide that information back with filtered out results so that it's very specific to Kate's use case. So we know who Kate is. She got authenticated. And then there are temporary credentials provided from authorization perspective. We can lock down her access to factual information. DynamoDB, and you can use other PostgreSQL or other databases as well. We can control what Kate, on behalf of Kate, which model to access, which feature of model Bedrock to access, which API to access as well. And also, within Kendra index, what are the documents she may have access to, and we filter out results. So that when the data is supplied to Lambda, it's making a call. Bedrock is only comparing information from a credit card perspective, which was supplied as a part of the RAG source, the data movement. So I feel that we have demonstrated that, yes, we can control the whole workflow. We can control data, where the data sits and the model. So check there. Next one is model and data evaluation. Like I said, you need a node counting machine. You need to make sure that data is right, models are evaluated. Now for that, let's start with data, because you need data for all sorts of purposes: evaluation, training, validation. Now to address that, we'll use a service called Amazon SageMaker. Now SageMaker is a comprehensive machine learning workbench where you can create, train, deploy your own models as well, all sorts of models. And it has all sorts of other features like MLOps and etc. Now one of the features of SageMaker is SageMaker Data Wrangler. Now Data Wrangler is a feature you can use to process and prepare data for machine learning use cases. And it has inbuilt things like it can ingest data from S3, Redshift, other sources, but also third-party sources like Databricks, Snowflake, etc. And once ingested, it has 300 plus data transformations built in you can use to process the data. Also, you can provide custom transformation as well using a framework like Pandas or PySpark, etc. Now, because this is a banking use case, one of the transformation Data Wrangler can actually provide that would be redacting PII data. So you would have ingested data for preparation, redact PII. You can do that. Data Wrangler can enable that. In fact, we have a full blog just on that for you to look at. So you can use Data Wrangler to ingest the data, process it, and have it ready for all sorts of use cases. Now, from a model perspective, because the model is in Bedrock and we have a feature of Bedrock called Bedrock Model Evaluation, the feature is under preview, which can help you evaluate, compare, and select the right foundational model for your use case. Like I said, there are currently 24 models in Bedrock, and then you can use it to actually compare models. And Bedrock evaluation you can do a couple of things there. First one is you can do automated evaluation. You pick up a model you may have in mind. From evaluation perspective, you pick up a task. Could be text generation, summarization, text classification, or Q&A, for example. This is a chatbot, so we'll use Q&A. And then you can use inbuilt data set to evaluate the model, and the report will sit in S3 for you to review and see, okay, if this is the right model or not. That is auto mode. Second is human-based evaluation. Now, what human-based evaluation allows you to do that is, not only you can compare the model like you did in auto mode, you can now compare it against multiple models in Bedrock, which is a differentiation. Also, you can do custom task type. Do this, do that. Maybe your task includes a bit of a generation, bit of a summarization, bit of a Q&A, and something else. So you can define custom tasks as well. And also, you can bring your own data set as well. So you don't have to use inbuilt. You can actually, that is allowed as well, but you can bring your own data set well. Perhaps the data set you created using Data Wrangler. So you can bring your own data set to evaluate models, validate model outputs, etc. So from a data quality evaluation and model evaluation perspective, we use a combination of Data Wrangler and SageMaker for data purposes to prepare the data for machine learning use cases, but also model evaluation, which makes it super easy for you to evaluate the models. Next gap is the auditing side of things. Now, for that, we'll use Amazon SageMaker. And SageMaker has very powerful tool called SageMaker Clarify, which has been around for a couple of years. We have done, or maybe 3 years, 2.5 years. We have done a lot of evolution of that. Because Clarify, the reason why I say powerful is because Clarify can do a bunch of things. It can help you detect and mitigate bias. So you detect it, and if it's detected, you can do some transformation operators, like, for example, balance. And balance, using balance, there are techniques called random sampling, random oversampling, for example. You can actually, if the bias is detected in data set, you can balance it, and you can address those bias gaps. And it has 20 plus bias metrics for you to allow to do that, so that you can actually detect it. So it's all inbuilt into that. Second thing you can do is the explainability side of things. Clarify is very powerful. It can help you explain what's happening in your data set, what's happening from the output of the model as well. And do excuse my handwriting there. So, and it uses what a popular algorithm called SHAP, or shapely values, which can, with SHAP, you can evaluate any output coming from ML models. For example, why Trevor got a specific approval for a specific home loan value as compared to the demographic, the age group, the debt, the equity, the pay. So multiple metrics, you can use that, and it will explain that why Trevor got that approval, because he had very less unsecured loan, like credit cards, hence it's impacted his scoring positively, he got that. So there are a bunch of things you can do from explainability perspective. Now, the way to use Clarify is through SageMaker APIs or SDK, or Python SDK. Using that, you can create Clarify processor jobs, and within that job, there is a handy method called baseline. So you can create baselines, one time going in and ongoing as well. And you can also create monitors. Oh, yeah. Bias analysis monitors, explainability analysis monitors as well. So like I said, you can do it in one job, you can do it in multiple jobs, automatically, kind of thing as well. So that way, you can not only detect bias, mitigate bias, but also explain your data set and models as well. Very handy feature. And what it does, it actually provides reports. There is a bias report, but also it's called model insights. The model insights is actually explainability reports. You can look at, you can review, work with your internal teams, your domain expert in that particular area to see how you can actually address that. And it's not one time, you probably have to do it multiple times through your life cycle, because drift happens. A new data comes in, customer may complain that, hey, I'm getting some inconsistent response from your chatbot. You probably do that as a part of ongoing thing in your life cycle. So that's checked. The last but not the least is guards. How do you instill some guarding inspection mechanism? For that, you use guardrails for Bedrock. It's a feature under preview. It allows you to create guardrails as policies. You can create filters. You can create topic filters. For example, I want to deny topics like investment advice from my chatbot, investment on crypto, property, etc. I want to deny all that, so you can actually specify that, and it will start to deny those topics. Also, you can do content filters. Content filters, you can apply that to requests as well, but also responses as well. Requests going into the model, but also responses coming out of the model as well. Content filters, there is already a bunch of filters like on insult, violence, sexual intent, all those things. And also, you can specify the sensitivity of your filter, low, medium, or high. Now, we have a banking use case. I'm probably going to do it a high filter. And also, from a guardrail perspective, you can specify custom message, deny message, like a disclaimer. For example, on request would be, sorry, I don't provide investment advice. Or, sorry, this model is not configured to provide that advice, kind of thing. And what I really like about guardrails is, beyond that, is you can set the guardrail and apply that to many models hosted on Bedrock. So you create the guardrail, and then other teams can just start to use it as well. So if you look at it, we started with our MVP approach. We wanted to take it to production. Some gaps were identified. We went one by one. For access control, we used combination of Cognito, IAM roles. For Kendra, we also used token-based user control, access control to apply that. For evaluation, for data prep, we use Data Wrangler. And for model evaluation, we use Bedrock model evaluation. For auditing purposes, so we are ready for audits. If someone wants to ask, we used SageMaker Clarify for bias and explainability side of things. And also from a guarding perspective, use guardrails for Bedrock. Now, one key takeaway is we see people doing first, second, and fourth mostly, generally, but they keep missing out on number 3, which is bias and fairness and explainability side of things in favor for faster deployments. So, but if you actually include that as a part of your scope, if you actually proactively do that, it will only help you get to production faster. Now, we had only 30 minutes or so. We covered a lot of ground. My suggestion is to actually take this learning beyond this room. So access AWS Skill Builder, which is our digital learning program platform. And on that, we have a lot of good stuff on these topics. Self-service, modules, trainings. On that, you can go deeper, but also keep it up to date, because this area is evolving very fast with new AI ethics frameworks coming in. So with that, thank you so much for joining this session. Please take a few seconds to actually provide a bit of feedback. And if you like this session, do not hesitate to give me a big thumbs up. Thank you, and enjoy the rest of the summit.